All right, so we're talking about this pseudoscience stuff and trying to understand what makes a good scientific study. So we've gone through all those ideas, those concepts about the variables, the independent, dependent, standard variable, control group, placebo effect, all that. So again, what is pseudoscience? Are psychic abilities science? Not saying that you can't use this to make decisions, but it's not a scientifically based decision, which sometimes that's all right. Sometimes decisions we make don't need to be grounded in science. That's totally fine. But we don't want to make claims that, oh, it is scientific when it really isn't. That's the point I'm trying to drive home here is I did my research. Okay, what was your control group size? What's the standard variables and the independent variables in your research? If they're not there, then we may be looking at pseudoscience. So if we can't see it, touch it, taste it, smell it, hear it, basically the five senses, if you can't use the five senses to prove it, it's difficult to call it science. There's the challenge. Let's make sure it's science when we're calling it a scientific study. So, all right. So, what is pseudoscience? Well, pseudoscience is viewed as, or considered, oh, let me make my font bigger. That way a little easier to work with. So, pseudoscience is non-scientific claims that appear to be scientific. So I think this, etc., etc. Where's the proof? Where's the evidence? Where's the science? So a couple ways we can throw flags up to help us determine if something is pseudoscience versus real science. So, all right, number one. We'll call this the big number one. If what somebody's claiming doesn't have a testable hypothesis, not science. That falls under pseudoscience. Number two. It hasn't been tested experimentally. How big's your control group? Well, we didn't run a test. So then how are you claiming this to be science? You have to be testing it. It has to be experimentally tested using all those variables we talked about in the previous lecture. If it hasn't, pseudoscience. So watch those infomercials. And sometimes on the very bottom of that commercial, it'll say, has not been clinically proven. Okay? Not scientific. That falls under pseudoscience. And then in number three. All right, so here's sometimes what happens is, oh, I ran a test, but the data doesn't support the conclusion. It doesn't support the hypothesis. It negates it actually, but the person's rejecting the results or ignoring the data because it contradicts them. It doesn't support what they wanted it to support, so they're just going to ignore the data. Those are all big red flags to tell us this is not science. What you're claiming is not scientifically supported. Now, again, I'm not saying things are always bad if they're not scientifically supported. It just needs to be acknowledged that it is not based in science. You can't claim this is scientific if it's not gone through this process. So this is, again, the push, the goal, the hope here. People will start to evaluate things a little bit more, keep an open mind, And again, I'm not saying you can't accept pseudoscience, but just acknowledge you're accepting pseudoscience. That's all you have to do. Say, yeah, I know it's not science, but I'm okay with that. I'm still okay with it. You're good to go. Nothing wrong with that. All right. So sometimes when we're looking at pseudoscience, we see people presenting untestable hypotheses. All right, so an untestable hypothesis is something that you just can't measure with experimental design. Imagine like personal preference. That is not scientific. I think Doritos are the best chips out there. How do I prove that scientifically? I can't. I can survey 100 people, give them a bag of chips or 5 types of chips and rank them and have them tell me which one they prefer. But that's just a preference thing, and nothing wrong with it. It's a personal preference thing. But you can't say it's scientifically proven that this is the best chip out there. All right, so watch out for untestable hypotheses. Sometimes, though, we come across these never been tested hypotheses. So they just didn't test it. So now here's the tricky part. This is kind of manipulation. If you don't test a hypothesis, you can't say, it was rejected scientifically. That's true because it was never tested. You can't claim it was rejected, but on the other side of it, you can't claim that it was supported. So again, don't let somebody use kind of wordplay or manipulation here to say, oh, well, you know, this hypothesis wasn't rejected. The next question you should ask them is, was it supported? Well, no, it didn't get rejected. Well, was it supported? If it's not been supported, you can't really claim anything. It's kind of dead or null. So, and again, the other thing we mentioned, sometimes research hypotheses are tested but not supported. As I mentioned before, the data doesn't back it up. So basically somebody's ignoring the data. And they're making a false claim about support for their hypothesis. So lots of pseudoscience out there. There is lots of science, but also lots of pseudoscience. Become more aware of this. Watch what you're doing when you're purchasing something. I saw this commercial. This is going to make my hair grow back. This is going to make me do this. This is going to give me bigger, stronger, faster muscles. Is this stuff even supported? You know, that's what we want to know. A lot of it, when they pay a big name celebrity to promote stuff, they're trying to use that name for people to go, oh, look, there's Barry Bonds. There's this famous baseball player, famous athlete, and they use it. That must mean it works. Not necessarily, because we don't have the research to show it. And it might actually be pseudoscience. So, all right. So when we're looking up scientific information, we're looking at information to be able to support our idea. We need to do some review. This is where we get into this. People say, oh, I did my research. Let's pay attention to the wordplay here. I did my research means you set up an experiment. What they should be saying is, I did my reference review, my literature review, I looked up case studies. That's very different than I did my research. So When you're looking for sources of information, starting source, go to a textbook. Now, it could be a paper book, it could be an online book. A published textbook has gone through massive amount of review. The book in this course has gone through, I don't know if it's 14, 15, 16 editions. Every edition, 30, 40, 50 people will go through that book and look for mistakes. Every edition, every time. New information comes out, it's added to the book. 40 or 50 people review it for accuracy. That's a pretty darn solid peer review. Textbooks are going to be one of your most reliable sources. And I'm not saying there can't be mistakes, because there are. I write textbooks and I make mistakes. The peer reviewers catch them. Sometimes something slips through and you go, huh. But if I'm going to trust a source, that's my number one go-to for a source of information. Now, what the vast majority of us do is we sit down, we pull out our laptop, we turn on our phone, whatever we want to say, and we Google. Google can be great, but we also have to be very careful when we're looking at Google. What is the reliability of the Google source? That is a huge thing to remember and think about. Ranking in Google does not mean accuracy. It means hits. And you can pay bots to hit your website thousands and thousands and thousands of times to move you up in the rankings. So keep that in mind. Position on a Google search does not mean validity. I have watched for over a decade students Google an answer to a question on my exam and get it wrong every single time. And I write a note. Don't Google. That answer's wrong. But it was the first one. Yeah, it's still wrong. All right? So you got to think about your sources when you're Googling and what is the reliability of that Google reference. So here's a quick guide. The lowest in reliability is here. Oh, not a smiley. The best in reliability is down here. All right, so that's how this table works, or this listing works. The least reliable Google source is a website that's trying to sell you something, because they're going to say whatever they want to say to make you buy their product. All right, I wouldn't trust a site that is an ad site. Not validity, not valid. The next least reliable, social media posts. How much stuff on Facebook, Twitter, Instagram, Snapchat, etc., actually has a reference for it? Don't trust it. Don't parrot and pass it on. There's the problem. The retweet. The retweet of garbage. The retweet of inaccurate information. That's why so many people don't know if it's true or not. Getting more credible. Institutional sites without references. All right, you got some more accuracy, validity, you hope, but if the references aren't there, I wouldn't rely on it that much. Get a site with references, now you're getting valid. You have more validity here. And an academic journal has the most validity, most reliability when we talk about a resource. Those journals are peer-reviewed, they've gone through a process, they are filled with references, there's tons of checks and balances to make sure this stuff is accurate. But most of us, we Google, we look at the first one and go, see, I did my research. No, you didn't. You looked for information and grabbed the easiest thing that there was, and you grabbed incorrect information most likely. So be careful, vet your sources, make sure you're using stuff that's valid, and get the facts that are backed by science.